Okay, here's the last video for our Unit 4 review on polynomials. In this video, we are going to be looking at this graph and interpreting this word problem with context. So, this graph represents a stunt pilot who is practicing a maneuver represented by this graph, and I'm going to go ahead and make this a teeny bit smaller so you can see all the details. Can I do that? It's taking its time. Here we go. A little smaller. There we go. Okay, so we have a stunt pilot practicing a maneuver represented by this graph. The equation for the stunt is given there. T is the number of seconds, so T is time, and then f of t, which is the y-axis, talks about his height in meters. So on what time interval, so they're looking for an interval of x values, or in this case t values, what t interval is the height of the stunt plane decreasing? So we're looking for decreasing, and I want to label that as an interval of t values. Our stunt pilot is going downhill here on the graph. Now, tracing the graph itself, it will give me the endpoints where he begins decreasing. So he starts decreasing right about here at 20, and he continues decreasing all the way until this valley over here at 60. So our interval for decreasing goes all the way from 20 to 60, and it doesn't include either endpoint because at the very top and at the very bottom of this hill, he's neither increasing nor decreasing. He's changing direction here, he's changing direction here, so we don't include those endpoints. The last question says, what is the maximum height of the plane? And if I take a look at this point a little bit more clearly here, it looks like it touches right there on the point, so I'm pretty sure that it's, let's see, this is 1, 2, 3, 4, 5 to go up 100, so it looks like it's probably 820. If I want to be positive that it's 820, I can do that in a couple of different ways. One of the ways is I know that this maximum height happens at time 20, right here. That's when he's at his maximum height. So I can take this equation, f of t, and I can plug in the number 20, 0.01 times 20 cubed minus 1.2 times 20 squared plus 36 times 20 plus 500, and I can solve that to see what the actual number is. It could be 820, it could be something else. But I don't have to plug that in and simplify and solve with all sorts of those crazy numbers in the middle. I could use synthetic division. If I want to find f of 20, all I have to do is take this equation and divide it by the number x equals 20. And I know that that looks like really gross division, but this actually works out really nicely, and the math I have to do is a little simpler than actually plugging it in to solve. So I would put a 20 in the top left corner. I would put a 0.01 for my first coefficient, negative 1.2 for my second, then 36, then 500. When I bring down my first term, 0.01, I have to multiply that by 20, and that is actually, it brings this over one spot and doubles it, or the calculator will tell you it's 0.2. When we add up and down, this just becomes negative 1. Negative 1 times 20 is just negative 20, so we have no more decimals anymore, which is nice. 36 minus 20 is 16, and 20 times 16 is 320, which I add here to find 820. And remember, the remainder of my division is my value, so it is exactly 820. And whether you solve the equation or did synthetic division, we can confirm that this is in fact true. If you have an equation this nasty, you would never want to assume, based on the graph, that you know what the y value is. You can always plug in the x value where the y value happens, just like we did in our classwork. That is it for our Unit 4 review. Good luck studying for the test. I'll see you on Monday.